Hello, welcome to this quick overview of the IBM code pattern on developing enterprise grade hybrid mobile apps with cloud native backend. My name is Shivakumar and I'm the author of this code pattern. When developing your enterprise mobile app that needs centralized hosting of data, use of cloud native services such as Cloud and NoSQL database for storing textual data and object storage service for storing image, audio or video data allows you to quickly go from idea conception to reality. The Mobile Foundation service available from IBM Cloud provides a scalable mobile access gateway for securely accessing those backend services, and it provides other essential mobile backend capabilities such as push notifications, app lifecycle management, app analytics, and others. This code pattern gives you step-by-step instructions for developing an Ionic or Cordova-based hybrid mobile application that securely connects to Cloudent and object storage services via IBM Mobile Foundation service. Following is the demo app that we will build as part of this code pattern. The app allows citizens to report civic problems in their municipal ward. After logging in, users can see the problems reported in their ward. Each problem report consists of a short description of the problem, the date and time at which the problem was reported, a photo of the problem, an address and geolocation of the problem location. Users can report a new civic problem by clicking the plus button. In the Report New Problem page, they can add a short description of the problem, take a photo using their mobile camera, and specify address through their device's geolocation. All the textual data is stored on Cloudent and images are stored on Cloud Object Storage. Let us understand the architectural flow of the My Ward app. User launches the mobile app, enters his or her credentials on the login screen and clicks login. Mobile app sends the user credentials to Mobile Foundation server for validation. Mobile Foundation server invokes the security adapter logic to validate user credentials and returns an appropriate response to the mobile app. For the sake of this demo, we will use a simple security adapter that returns success when password is same as that of the user, that is password equals username. If user authentication succeeds, mobile app proceeds to show the home page. As part of this, it makes a call to Mobile Foundation adapter to fetch the data from Cloud and NoSQL database. Mobile Foundation adapter fetches the data from Cloudent and returns it to the mobile app. The data fetched from Cloudent will have references to the images stored in Cloud Object Storage. Mobile app makes a further call to Mobile Foundation adapter to get the authorization token for interacting with Cloud Object Storage service. Mobile Foundation adapter makes a call to Cloud Object Storage Services Token Manager endpoint to get the authorization token and returns it to the mobile app. Mobile app initializes image caching plugin and asks it to use an HTTP header of authorization equal to the value returned from Mobile Foundation adapter while fetching images. Mobile app displays the data obtained from Mobile Foundation server as a list of items. The image caching plugin running on the mobile app downloads and caches images from Cloud Object Storage. User clicks on one of the list items to see more details. A detail page is shown consisting of image and geolocation marked inside Google Maps. Back in the home page, user clicks on the plus button to report a new civic problem. A new page is shown where user can enter a description for the new civic problem as well as capture image and geolocation of the problem spot. User clicks on submit button. The mobile app uploads the textual data to Cloud and NoSQL DB via Mobile Foundation adapter. Mobile app creates a thumbnail image by resizing the captured image and uploads both the captured image and the thumbnail to cloud object storage. Other users who click on the refresh button on the home page and those who log in afresh are shown the updated list of problem reports. Following are the steps to build and run the mobile app and to set up the required backend services. First, we will set up the command line interface for Ionic and Mobile Foundation. Since these are installable as npm modules, we first install Node.js. Then we install Cordova, Ionic and Mobile Foundation command line interface. Since our MFP adapters are written in Java and use Maven for building, we install Java SDK and Maven as well. Next, we create Cloud and Database service and populate it with sample data. We generate an API key for Cloudent for specifying it in Mobile Foundation adapter. Next, we create Cloud Object Storage service and populate that as well with sample data. We create a service ID and API key for accessing the objects in Cloud Object Storage. For this, we will use IBM Cloud Identity and Access Management dashboard as per the instructions in step 3.2. Next, we create an instance of Mobile Foundation service and set up our Mobile Foundation command line interface to connect to it. With this, we have the required backend services set up. Next, we clone the source repo. The source repo consists of the Ionic mobile app and two Mobile Foundation adapters, MyWord data adapter and user login adapter. The MyWord data adapter consists of REST APIs to fetch or post data from Cloudent as well as a REST API to get authentication token from Cloud Object Storage Service. The user login adapter consists of a simple MFP security adapter for validating the user credentials. It returns success if username and password match, that is, password equals username. We will specify the credentials for connecting to Cloudent and Cloud Object Storage Service in the MyWord data adapters configuration file. Then we build both of these Mobile Foundation adapters and deploy them to our Mobile Foundation service. Next, we register the Ionic mobile app to the Mobile Foundation server. The REST APIs of MyWord data adapter are protected by using an OAuth security scope. We map this security scope to user login security check through Mobile Foundation dashboard as per the instructions in step 6.3. Finally, we build and run the Ionic mobile application as per instructions in step 7.4. In case you run into any problems while running the application, then you can inspect the logs and debug the app as per the instructions here. Let us see the app in action. I'm launching the app from my Android phone. On the login page, I will use an username of test and the password is also test. When I click sign in, the app will try to validate my credentials by making a call to Mobile Foundation adapter. Once authentication succeeds, App will make a call again to mobile foundation adapter to fetch the data from cloud and database. The data is now loaded, and this is the list of civic problems reported in my municipal ward. I can click on a problem report to see the details. The details page shows problem description and its location on Google Maps. The photo of the problem location will be loaded from cloud object storage and it will be cached locally. Back in the home page, I can click on the plus button to report a new civic problem. I can enter a short description of the problem. Take a photo using my mobile camera and grab my device's geolocation. Finally, I click on submit button. The app now uploads the data to CloudEnt via mobile foundation adapter, and then it uploads the image and its thumbnail to cloud object storage service. Uploads are successful and the new problem has been successfully reported. Back in the home page, I can see the new problem that I reported and its details. The code pattern also includes detailed step-by-step instructions for developing the app from scratch. These detailed steps also help you in reusing specific portions of the app, like adding preemptive login to an Ionic app by using Mobile Foundation Security Adapter, or connecting to Cloud Object Storage Service from a mobile app for storing and retrieving images. In subsequent IBM code patterns, we will show you how to enhance the simple mobile foundation security adapter to connect to an enterprise LDAP server for validating user credentials. How to add social login such as Google login or Facebook login to the Ionic app. How to make the app offline first by using Mobile Foundation JSON store, and how to leverage other mobile foundation features such as direct update, push notifications, and app analytics. Hope this code pattern and the upcoming ones help you in faster development of your enterprise apps. And thank you again for your interest in IBM code patterns.